Aedo. And background, I work at Labs. I'm the CTO. I started at Arthur Anderson, so I have kind of a background in IT and operations and that kind of stuff. And as it says right there, I had nothing to do with Enron. I left before Enron, not my fault. I know some things about OpenStack. I'm kind of active in the OpenStack community, and I'm trying to stay active in the local, especially LA, kind of ops and sysadmin community. I met Vint Cerf once at a Google party, which was really cool, and we talked about the thing that he was worried about at the time, which was 3 years ago, and he was really worried about the future ability to actually read data. So he was talking, we talked for probably half an hour, 20 minutes about, think about, we've got these old 5 1/4 floppy disks, but jump ahead 100 years or 150 years when all of the spinning media and even SSDs, everything has died. The different old media sitting around, will people be able to read it and do anything with it? And that's, I guess, the kind of thing that a guy like him thinks about. I've been in the Grand Canyon sometimes. So I work at Morph Labs. I'm not going to pitch Morph Labs or a venture-funded company. We work on OpenStack systems, and we kind of take a systems approach. So one thing that differentiates us from a lot of other people in the OpenStack world is that we truly believe OpenStack is fantastic software, but it can only be performant and reliable on really well-designed hardware. And there's a lot of people in either camp. Kind of, you read from Morantis saying, pay us enough money and we'll make OpenStack run on anything you want. And that's the company with the card who did the voiceover for the, what I'm talking about? Anyone? No.
Twitter? You got Piston?
No, not Piston. They just finally came out with their cloud. Nebula, yes.
Oh, okay.
So anyway, and they kind of have a similar, well actually no, they basically do a very limited menu. Anyway, work at Morph Labs. I know some stuff about OpenStack. The agenda today includes this stuff. Really what I want to do is help with everyone in the room kind of go through a framework to think about the things you have to consider when you're building a cloud, whether it's OpenStack or something else, but primarily OpenStack. And since this is a room full of really smart people, hopefully you guys will all chime in as well. Feel free to interrupt me, feel free to say, wait, that math doesn't look right, or share stories certainly about things you ran into while scaling out your systems. And actually DreamHost knows a lot about this, so maybe the DreamHost people in the house will speak up on that. And the very first thing I want to start with actually is a huge thank you to the team that did the OpenStack operations guide. They, Rackspace put them up in Austin for 5 days, and they pounded out this fantastic guide, which really is from an operations side, it is the #1 best place to start if you're thinking about OpenStack, because they really go through all the different components and a lot of the thinking around how to tie them together and what you should worry about or think about when you're building an OpenStack system. So their ops guide is fantastic, and if you are and think about OpenStack in any way, you should read it. That's Jeff Bezos when he learned about OpenStack. He's besmirching his trousers right now in that picture. All right, so those of you who want easy answers, you need unlimited money, unlimited time, an organized team of geniuses, so just some really smart people, if you can get them all together in a room and to work out your OpenStack capacity problems, that's what you should do. And make sure you've got total agreement on all sides in advance, in writing, so that the goal never moves or changes along the way. So if someone says, oh, we need a cloud to serve 10,000 virtual CPU with this kind of performance metric, don't let them change it on you. That's the easy answer, but those don't ever happen. So let's say you're getting started and you have some capacitors and chips and stuff, and you want to turn it into an awesome, awesome cloud. Best place to start is with a spare server. So if you have an extra server laying around somewhere, you should get that and hook up a keyboard and a monitor and put DevStack on it. And again, so who here, actually I should have started, who here has deployed OpenStack or works actively in OpenStack?
Wait, well, it works actively.
These are very different. Right. Works with OpenStack, has deployed it, has OpenStack experience. Okay. So DevStack is really, really useful. It's really the right place to start, in my opinion. It is not at all ready for production, and I think it even says, it doesn't say on this page, maybe it does later on, but in there, like, never ever use DevStack for production, period. It's not meant for that at all. You can't scale it, even though you can take DevStack and connect multiple nodes to deploy DevStack on a controller and one as a compute.
It's not called ProdStack.
Yes, exactly. But it is really, really the right place to start, and you can get a lot of familiarity with DevStack. So if you are thinking about doing anything with OpenStack, really start at DevStack, and you can launch DevStack on a VM on Amazon or VirtualBox. There are Vagrant. Well, you don't need Vagrant. Use a Vagrant Ubuntu and then put DevStack on it. Anyway, DevStack is awesome. Has anyone here run DevStack?
Don't run it on your laptop.
Why?
Because it crawls into all kinds of stuff and like opens sudo wide open, just all kinds of.
Don't
Yeah,
run
yeah,
it
you're
on
running
your
it
bed.
on
Oh,
okay.
You gotta encapsulate for sure.
Yeah.
I'm off camera right now, right?
Yes.
I'm just having a drink of water off camera. So my throat doesn't go dry. Yeah, don't run DevStack. Like run it in a VM or a container. No, yeah. And so, okay. The main, after you kind of have a familiarity with OpenStack and you've read the operations guide and stuff like that, the next really important thing is what's your workload or who are your users going to be. And usually the first crossroad is between public and private. And they tend to have radically different considerations. So like if you're going to a private cloud, you probably know your users, you probably know your workload really well. Bonus points if anyone recognizes this particular cue card.
Tron.
Those of you wearing Fight for the Users shirts should
right.
have known that. So when you're talking about a private cloud, internal use or whatever, you almost always have a really good handle on who your users are going to be and what your workload looks like. You have far fewer variables. You'll know about networking options. You know about storage. You probably have a more meaningful or specific budget for it. On the other side, you're also more likely to be required to use equipment you already have on hand, which can be problematic. So anyway, private cloud is usually a little bit easier because you definitely have fewer variables. But public cloud is usually a very different story, and you don't know your users. So you might have a really happy lady, a happy black guy, an angry Asian. British Special Services might be using your public cloud to track terrorists, and there might be a really scared old lady using your cloud. Point being, these all have radically different workloads, and so it gets really hard to profile and target a compute node that works well for them. And at the end of the day, in any, the most important start is your compute node and scaling and figuring out kind of how to balance your compute. And secondarily, it's the networking side of it. But the networking tends to be more flexible. The compute is the one big expensive piece that once you invest $100,000 in servers, it's hard to really adjust that or tweak it when you realize that you made some mathematical error and you have half the RAM you actually need. Little things like that. The networking is a little bit easier to tweak and Everything else is just little pieces around it that are easy to add or change. So, cool thing about public cloud is usually you're working with someone that's kind of greenfield and they are, you can dictate the equipment when you're building it out. And if you're lucky, you'll have unlimited scale and they'll really scare Jeff Bezos. And the other thing that really comes up a little bit more in a public cloud consideration is your provisioning model. So in a private cloud, again, it's much more likely to be fixed in scale. You're not too likely to need to redeploy compute nodes or add a lot of capacity on a regular scale. But if you're doing public cloud, hopefully you're doing that all the time, and you're finding, hey, we've hit our threshold again, and we need to add 6 more compute nodes to the cluster. At which point, how you stand up those compute nodes becomes really important. And so you have to, it's good to be able to do it fast. So for instance, Rackspace only takes about 2 minutes to stand up a new compute node and add it to their Rackspace cloud. Mirantis is trying to make it a little bit easier with Fuel, Ubuntu, with Juju. They're trying to make it really easy to stand up and manage clouds and deploy new nodes. Down the road, the most likely scenario is that everyone uses OOO, which is OpenStack on OpenStack. So your base image for OpenStack is, your base image for an OpenStack compute node, for instance, would be an image within your OpenStack environment, and you plug in a new compute node, and it basically uses Pixie from your OpenStack environment to install everything it needs on that node. It still needs some config management. So the idea really is that you would use that for your initial boot, and then your Puppet or Chef or whatever would finish from there. How does DreamHost deploy new compute nodes?
We're working on it.
All right. So the one common thread, public, private, anyone deploying the cloud, is to try to figure out what kind of workload you need to support and that you should profile it. So as much as possible, get a sense of what you think your VM will need to supply. Like I said there on the fourth bullet, can anyone have really great profiling methodologies? Like if you guys want to see, has anyone ever really done that and tried to figure out what you would need to provide in a VM for a specific kind of workload?
I guess I'd point out the irony of when you start doing this is that logs end up taking all your RAM over time.
Yes.
Because all of your DOM-Us are storing logs to their file system, and as that file system is trying to cache as much as it can for RAM, they're all going to start using more and more RAM just to cache these logs that are on disk.
Right. Which I get to it later on, and I talk really about IOPS and IO being the real factor behind everything. That's always going to be, at least right now, it's primarily the bottleneck, because you can solve IOPS easily by throwing huge PCIe SSDs, but so expensive it doesn't make sense. There's some other considerations. I guess I'll get to that. But yes, logs and just kind of the rampant growth and hammering of I/O is what does tend to kill it. It being the compute node. So when you're thinking about scaling out or building your OpenStack environment, you do have to pick the hypervisor. And usually, picking a hypervisor is best done with some knowledge of your workload, because some hypervisors work better for some things. So the 4 major ones that OpenStack supports are Hyper-V, ESX, Xen, and KVM. KVM is by a really long shot the most popular within the OpenStack community. I had some of the graphs from the OpenStack survey they did before the last summit. I don't know what happened when I put the graphs in here. I was probably lazy. But KVM was at the top in terms of hypervisors, and it has the most active community of people making it work well. So if you are out there, at least make it work well with OpenStack. When you contact OpenStack, it's got more users and more active users, so you can get help if you are running into weird problems. Anyone have any questions or experience with these hypervisors, especially in relation to OpenStack? Any things they'd like to share?
KVM works great.
My measure, yeah.
I use KVM without OpenStack, so
Yeah.
love it.
So then we get to compute density, and this is the one, designing your compute node when you're talking about scaling up a cloud. Primarily the compute node is the one thing you really worry about and the one thing that you have to try your best to get right. So this is where you think about how many physical cores it has, what kind of oversubscription you'll want to do on virtual cores on top of physical cores, and then that will dictate how much RAM you'll need to put on the box and how much local storage you'll need, or remote storage if you're going to get into that. So the basic formula really is your overcommit fraction times physical cores divided by the virtual cores per instance. And the other major thing is whether you're going to have ephemeral storage local or remote, and if you want it to be local, how much you actually have available. So I have a slide there on the kids to know a little bit more detail there. Anyone questions? Feel free to interrupt.
I've always just used RAID 10 on the local feed just as fast as I can. Would anyone disagree with wanting to use RAID 10?
Nope. And I actually have, in 2 or 3 slides, I have a specific kind of run through on thinking of RAID 10, some SAS disks, how many IOPS you can expect on that, and how that backs up, and how many performant VMs you can expect to host on that. So the major vectors really are, and all of these things come into play, right? Because you can make a fantastically awesome, super performant compute node with lots of, just tons and tons of SSD space if you've got $100,000 per U in your rack, which not many people do. Usually you're limited to around 4,000 or 5,000 per U, or somewhere closer to that, which has a pretty severe constraint on how much performance you can get per compute node. And then, like I was saying earlier, public or private, whether you're getting new equipment or having to repurpose something that you had before. And then the space and the power and the desired performance, and really how much compute RAM storage per node, which in large part will be driven by how many IOPS you think you need to design the node for. So this is the easy way to calculate, to estimate possible IOPS for a disk. If you have to use spinners, and you know exactly which disk you have to use, you can do some relatively simple math and figure out roughly how many IOPS you're going to get per disk. So this is usually, and there's a nice little source on the bottom. I'll share the slides later, so you have notes and all that. I want something. This is true. So, a graph. This is really just to illustrate, it's not very interesting, but just the fact that as you can really push the density way, way up in terms of virtual CPU on a compute node. So you can do 32 core box and a 4x oversubscription and have tons and tons of cores, but you get up to that 110 and you need a terabyte or a terabyte and a half of storage. And if you're talking about performance storage, it starts to get hard to get that much storage on a single box. So if you, let's say, start with 32 physical cores and 3x oversubscription rate, and 50 IOPS per VM, so there's really, this really goes all the way back to profiling, all the way back to thinking about what kind of workload you're going to have. 50 IOPS per VM is on the low side for a relatively low traffic, just a simple VM, like someone running a blog that gets 7 hits a day and maybe 12 on a really fancy day. They're going to be well under 50 IOPS, and then someone else who's doing something crazy and hammering a database is going to need, realistically, 150 or 200 IOPS. But if you average it all out, and you're going to say 50 per VM is what you want to target, then if you're pushing a density down to 100 per node, you'll need 5,000 IOPS on that box. If you only have 12 disks available, and you've got a 10K SAS disk, RAID 10, for read operations, you're only going to end up with 1,500 IOPS, which isn't actually enough to support the density of the cores, which probably leads some companies like DreamHost to create something like Ceph, where they can disconnect the compute from the storage. So, I don't know if you guys want to talk at all about it, but what they've done with Ceph and for Dream Compute is use Ceph to host the base disk for the VM so that your compute can scale completely independent of your storage, which is great, but it's also complicated because then you really need to worry about how many IOPS your Ceph cluster can deliver back to that compute. So it doesn't solve the IOPS problem. It just breaks it up and puts it in a different place. Has anyone here ever done that? Like hosted VMs with a SAN-backed, like a SAN-backed.
I mean, I've got all our VMs are running on shared storage, which is really terrible because you can't isolate. You can't easily give a lot of IOPS to some VMs and take it away from others.
Right.
So, I mean, it just so we haven't hit the wall or anything.
And it really compounds the noisy neighbor problem,
Right.
where one VM can potentially impact everyone who has, anything on that shared storage node.
Yeah, so I guess I come from a privileged enterprise arena where the workload is a little more predictable. But all of, and we're also NetApp cores, so we have certain privileges there where all of the VM images are all nothing's ever bigger than 8 gig. They all live in NFS. They're all QCOW2, so they're relatively light as far as glance having the single base image, and it's only being delta from there on out. But as far as when you impart identity onto a new VM via Puppet or whatever, and the identity is really a composite of NFS mounts to another filer that has all of your app data on it. That's the best way to scale things up that we found on the enterprise side, where we have some leverage into the nature of the workload.
Right.
But the public side is a completely another story. Absolutely.
Yeah.
And then that still sucks your block, right?
Yeah, and I'm not in the block period anyway. I would avoid ICE because they like to play at every turn if I could. Like I just have no need for block storage in my environment. Because I can dictate that, your MySQL is going to run on one NFS volume for its NODB table space and another NFS volume for its transaction logs, and because Puppet just told you to do that, right? So I'm very, again, privileged in that I can dictate those sort of things from on high. So
That's exactly the private cloud advantage, or that you have a much greater understanding of what you need to target and what you can tweak to meet that. So, let's say you kind of did this early math and you figured out how many IOPS you actually could do. So you can start from the other side and say, well, I know I can only support about 1,500. So really that's going to be about 30 VMs per node, which means I only need 12 physical cores that I'm doing pre-X over commit. And that will dictate the amount of RAM you get in the box and what storage you actually need to still deliver kind of a reliable level of performance if your VM storage is all local. Main point being, this is the exercise you should do before you start buying hardware. and or if you have hardware, then be honest and do some calculations and be really like, you've got to be honest, because if you're not, you're gonna screw yourself over. And you know, down the road, because you'll eventually hit a wall, and you'll find out that you really don't have enough of something, either RAM, CPU, or IOPS. It's almost always going to be IOPS that burn you.
So it's take what you've got, run these calculations, and then migrate a bunch of crap
Exactly.
before you get burned.
You know, and it gets also complicated if you are kind of have homogeneous compute nodes. So if you're bringing in a whole bunch of different equipment, or equipment with different scale, different amount of RAM, or different number of cores, or whatever, then at least in the OpenStack world, you start to get into affinity groups, and you have to get a little bit complicated with your scheduling if you want to make sure that, you know, let's say you're mixing AMD and Intel, and you have a particular image that really works much better on an Intel KVM backed versus AMD. You know, when you start mixing hardware, it really like complicates things crazy. Can be advantageous. Certainly if infrastructure as a service is good and makes sense for you and benefits you, then you do a little bit of work up front, and then you have a lot less work to do later on, and your users don't need to come to you every time they need a new VM, and it kind of can speed up that test cycle potential. And you know, and I'm much to the chagrin of some of the other executives in my company. I'm the first one to step up and say, this workload, this customer makes no sense. This is not, you know, I know that you have an in with the guy and they should be using OpenStack in your opinion, but we've just spent a day talking to their users, you know, their people about how they use it. This doesn't make any sense. They get no benefit out of it. And, you know, we've walked away from deals because of that. So there are certainly times where if you have no need for infrastructure as a service, what are you getting out of OpenStack other than maybe the ability to snapshot that VM now and then? Not too much else. So KVM, just straight up KVM sometimes is awesome. All right, so compute node density. Now let's talk about storage. So if you're in a private cloud situation, one, tape drive like this might be sufficient storage for your needs. But you also might need a whole room full of tape systems to store your data. And you really need to think carefully about scalability and whether you can add storage to your system. So within the OpenStack world, there is basically object storage and block storage. Object storage natively, the OpenStack project is called Swift, and that is their object store. Inktank, DreamHost's sister company, spin-off, whatever, created Ceph some years ago and have been working really hard to make it work really well with OpenStack as a direct replacement kind of to Swift, and also Ceph allows you to do block storage on top of the RPDs. And there's also Gluster, which is similar to Ceph, has some, technically, architecturally, it is not similar to Ceph. It's very different. They made some really big different choices. Gluster has been around longer, was purchased, I think, this year or last year by Red Hat. Have they not been around longer? Am I wrong about that? I thought
yeah, they've certainly been used longer. I think they were about 2 years ago though, actually.
Oh, you're right. I think it was 2011. But no one likes Gluster, right? You can edit that out before it goes on YouTube.
You can pin it on me, it has a terrible reputation.
Yes, Lars says it has a terrible reputation. And I can honestly say I have no experience with Gluster, so I know it's out there. I don't know how it works. I don't know how well it works. It's slow.
It weighs a lot, right? Like, it's pretty easy to get it. Yeah.
So, yeah, I mean, all respect to our host tonight, Ceph is kind of awesome. Crush map and some of the thinking around how to rebalance the distribution of data in Ceph is fucking awesome, and I do think that Ceph will, I mean, it's already more popular than Cluster, at least in the OpenStack world, and people tend to say better things about Ceph. And I think we'll continue to see it kind of getting deeper and deeper into the world. React CS is also being used for object store, not quite as cleanly natively connected to OpenStack, but they are working on making it work pretty well. Point being, on the object store side, there are a lot of options, and the object store is the one piece that's really easy to scale. Like, all of them are built from the start to basically let you just add more nodes to the system so that your object store needs grow. It's easy to scale up to
Well,
it. So,
sort of.
I mean, it's not plug and play.
Well, it's not just that, but I mean, if you make a decision from the beginning that your Swift cluster is going to be small, you can never make it big because you make all your decisions from the beginning of how it's going to shard, and
Right.
assumptions break down.
So they're fixing to some extent. Havana will see some big changes on that front. And so Havana is the next OpenStack release for those of you who are not OpenStack nerds. And you know, Swift is an interesting case, and just in the so I was day before yesterday I was up in San Francisco for conversation with Hirschfeld and some other people from OpenStack, really talking, people from the board talking about what is core OpenStack, and what was interesting is in that world of core OpenStack, Swift is consistently on the edge, primarily because people consistently don't like it, and people consistently are not happy with it. And so it's kind of interesting in the context of what defines OpenStack, the minimal, core pieces of OpenStack. It's almost like the edge.
I think a bigger problem with Swift isn't its quality, because it does largely what it's supposed to do if you know which features actually work as advertised and which ones are bullshit. But the bigger problem with Swift is that some people don't understand object storage, and they've got such tunnel vision on we're going to get vSphere for free somehow, that it just gets so much less attention because people are so excited about virtualization, and they don't understand why they need objects so badly.
Right. Very good. But it's getting better. I think in the next, probably within a year, a lot of those kind of scalability, sharding decision problems, and redistribution, rebalancing problems will be solved in Swift.
IBM's doing some serious work on that.
Yeah.
Change the number of vNodes yet? I think that was the largest problem.
What?
You can't change the number of vNodes, right? Did they fix that yet?
I think it is. If it's not,
I have no idea.
Yeah.
What it is.
I can't speak with authority because I've never, other than just a little bit screwing around with DevStack, I've never run Swift.
So it's like, once you build it, you say, here's the number of vNodes, and then you can never increase it without...
That's, as of Folsom, I know that.
Well, so you can increase the number of nodes you have, but it's just.
But you always have the same number of vNodes, right?
Oh yeah.
Right.
Right, so you're ultimately limited by
Your chunks.
your chunk size. Yeah.
So anyway, when it comes to storage, think about scalability, because you do want to have a scenario where she can come in and say, I need more storage. Say, no problem, I have more tapes, and then she'll probably be like, oh, did you see Breaking Bad last night? God, that was fucking awesome, and and then he'll just stare at her for a while, and eventually she'll be like, hey, so are you going to take now? Point being, you really want a scalable storage solution, which is problematic on the block side with some solutions. So, for instance, even only Gluster and Ceph, primarily Ceph, is the cleanest scalable block storage stack for OpenStack. Period. There's nothing right now that competes with it at a reasonable level. In the future, there might be some other things that work well and are scalable. We use Nexenta a lot as a block storage back in private clouds, and it works pretty well. We worked actually with Nexenta to build in some nice things to the API to help balance it a little bit better across. So you just add a bunch of Nexenta nodes, so you don't get, like if you have 5 4 terabyte nodes, you can't do one 8 terabyte block store, but you can spread your block volumes across them pretty easily. And so there are options out there. And I don't know, does anyone have any? Actually, I've never used NetApp Aedo. Does anyone here?
I don't use the sender interface to it. All I do is my public manifest mounts my common NFS volume to one of the Nova instances, and I call it a day. I don't use it for really anything other than that.
It's pretty good plan. It makes it kind of easy to migrate things with all the.
And that is right. That is the way that the built-in live migration in Nova wants to work. It just wants a shared file system for instant storage,
right?
Rather than handing ones back and forth. It's a lot. It honestly is more elegant. But then you have to be pretty concerned about the I/O pattern of those things, because you'll smash a filer relatively quickly if you get a lot going on it. But in my workload, again, being the spoiled enterprise guy, I can control that.
Right.
You're not using that local VM storage for anything really, other than collecting, var log, syslog. That's about the only delta on it.
Right.
And then there's the issue of updating it, which increases the delta against the QCOW2 baseline. But our policy is, okay, well, a new Ubuntu pod image is out. You've, of course, written public manifest for everything you want to do, so just destroy and recreate your node. It's a big deal. So it's our policy.
And Ceph, I think, works a similar way. Librados sits between, right, KVM and the storage.
Yeah.
And provides a really very similar, at the end of the day, functionality where every compute node has access to the same pool of storage. So if you want to live migrate a VM from one compute to another, or if a compute node completely dies and you want to start it up again from a different compute node, it just starts up. Kind of work.
KVM with the right commands, yeah.
What's that?
You just turn on KVM with the right commands.
Right. So storage considerations important, but probably, well, they can be as significant as your compute node considerations, but more often than not, at least in my experience, compute is still the number one thing you have to worry about and fix first, and then the storage stuff kind of comes after that. So networking, you don't want your physical network.
What you get in our data center?
Or your virtual network to look like that. You really like to look a little bit more like that. Although, kind of help you if you actually need to replace any single one of those.
Do you have already?
So you need gear. I recommend hubs because they've got the uplink port right there, and see the uplink port goes into the number 5 of another one. You can stack a lot of those together. Actually, so networking is the other. Networking is really, in OpenStack, it's really very difficult to change after the fact. Bordering around impossible to change after the fact. So it is really good to think about what your needs are going to be, whether you need to have VLAN separation or complete isolation between tenants or projects within the OpenStack parlance. If you're in a private situation, it probably doesn't matter, and it might even add more complexity than you actually need, especially if you're not building out a massive, huge, gigantic cloud. You might want to just go with simple flat DHCP, and then then go to VLAN, Nova VLANs from that, but then that will be updated soon. As soon as there is a viable migration path from Nova for running networks to Neutron, which used to be called HANA. And so the Neutron project is the software-defined networking project or piece of OpenStack, and the design is primarily meant to allow vendors to create plugins that will allow OpenStack to manage a software-defined network.
Do you still use VLANs with Neutron?
Yes.
Yep. The provider network model is what we want there.
So, things you have to think about are you going to have enough IP addresses for whatever you're trying to do, especially if you want to expose VMs to the outside world. You need to use floating IPs, and other really big one these days is IPv4 versus IPv6. And if you have any hope of serving, in 2 years, you should probably bake in IPv6 from the start. The landscape is evolving rapidly in the world of OpenStack software-defined networking. OpenFlow, for my money, is probably the thing to bet on, or at least some level of OpenFlow compatibility. And I like what NEC is doing with programmable flow. And they're really putting they're committing a lot back into that world and sharing a lot. They also want to sell some kind of cool programmable flow controllers, which I started to play with, and they're kind of awesome. All of them, there are a lot of options, and they start to get horribly complex and very confusing. But from just from a career perspective, I will say, you have the opportunity to start working with software-defined networking on your company's dime, you should do it right now. Because the future, let's say 5 years from now, that is going to be probably one of the most valuable things you could have in your tool chest. The world will go there, and there's going to be a tiny, tiny number of people that have deep experience and expertise in it, so you can be one of those people. And OpenStack is kind of a good place to start playing with it and kind of build up that experience. Last thing about hardware, obviously don't ever use a hub. Delta Networks. I know you guys know about Delta Networks. Who else here? Anyone? So Delta Networks is, I think, Chinese or Taiwan switch vendor, hardware maker. They build these kind of awesome 10 gig switches that they put a Dell sticker on. Or you can buy it, and if it gets the Dell sticker on it, then it also gets Dell's awesome switch system, and the Dell sticker, and then the Dell will charge you $15,000 for it, or Force 10.
Yay, Force 10.
So you could do that and get it from them for $15,000 or however $18,000, or you can get it from Delta for $4,000. It is literally the exact same. It just does not have the sticker on it, and it does not have the OS. And then you buy the Cirrus, right?
Cumulus?
Cirrus OS. What's that? Cumulus. No, you're right. Cumulus OS. Thank you. Sorry. Thank you. Cumulus OS. For $400 or so license per switch, I think it's in that range. So you can end up about $5,000 for 48 port 10 gig switch. That is literally the exact same as that $15,000 or $18,000 switch, and that is that model is scaring switch vendors, because that combined with software-defined networking is the future. So open standards, no more proprietary shit, and switches that you don't really have to think about. Switches that you just plug in, and you have one source of truth on your flow controller or your OpenFlow or whatever, that defines what the network should look like, and it's built dynamically on the fly as needed.
Switches you configure with Puppet.
I mean, not even, yes.
Switches where if config tells you what's going on local
configure
ports.
with Puppet, and it's even better that it's the point where you tell Puppet, listen to the commands from the flow controller, and the flow controller is API driven, and when someone spins up a new project and says, oh, I actually need a VPN route between this project and this project, the first packet that goes through ends up defining the switch and the flow, and it's awesome. Absolutely the future, absolutely the thing to start learning if you can.
Where's it at right now?
In production here.
Yeah.
OpenFlow?
You guys are using Midakura, right? Okay, well, not
Maybe, and I don't think so.
Okay, thought it was,
But
but
we're using Cumulus, so they were.
I think it's Cumulus. I mean,
Right, yeah.
Last I
Pretty sure
heard
we're
was
using-
at the last meetup where we talked about it. I think it was Cumulus.
Well, Cumulus on the Switch, but at the,
The flow control level.
so,
Oh,
and
yeah.
the layer 2, I think it's Metacura, and layer 3 is actually a OpenBSD, which you
I
guys
think they were using Nicira because.
Oh, Nicira.
They're using
that's-
Nicira layer
that's right,
2, and they're
Nicira,
not using
Midakura.
Nicira layer 3 because Nicira layer 3, contrary to what the salesman tells you, does not fucking work.
Nicira, not Midakura. All those names confuse me. So Nicira, and I don't remember the name of the project that you guys open sourced it, but it's basically an OpenBSD.
A conda.
Yes, an OpenBSD VM that gets launched to do the L3 routing within each tenant, which is awesome. And it's a really cool project, and especially I'm a big BSD fan, so I love it. So it's legit. It's early days in terms of software-defined networking, and it has. And all the big switch vendors worry because it's going to really, really change the landscape for the better of the users, to the benefit of the users, and it's kind of some cool stuff. So I'm almost out of slides and almost done talking. So I'll talk briefly about the cloud controller because you don't really have to worry that much about it. In the context of open cloud, your cloud controller is running your database and your message queue and running the core services and the API endpoints, but OpenStack does make it legitimately easy to put those endpoints on a couple different boxes. If you find that you're having some scalability problems on your single box, the OpenStack H8 project is very active using Core Sync and Pacemaker well, I'll get to that in a second. I'll talk about when you outgrow your cloud controller. But it's in the broader context of designing a big cloud. The cloud controller is really just 1 or 2 or 3 boxes, and if you've got 3 racks full of servers, those 1 or 2 or 3 boxes aren't that big a deal, and they don't have anywhere near the irreversible impact in poor design that you'll find if you screw up your design of the compute node, because the controller is a little bit easier. So let's say this is your cloud controller, and you are growing your cloud, and then you find you outgrow it, and your temptation might be to augment it and make it somehow a better cloud controller.
Jesus, that's beautiful.
But don't do that. If you outgrow your first pass of the cloud controller, build a new one and build it right. And while you're at it, do 2 of them, make them HA, and then when you outgrow that, the next step is a cell, and you can legitimately in OpenStack wrap. A cell is basically compute. You can have multiple cells all behind one API endpoint. So this one cell, the cell is basically breaking off the message queue and the database, which are the things that that's where you'll hit your limit of scalability. Really is DB calls and messages on your queue, and so you can wrap that up in a 4,000 or 6,000 vCPU cell and just keep building those all behind one endpoint. I don't actually know anyone who's built on a huge cloud with dozens of cells yet, but theoretically it's possible, especially if you build it like Unimod.
I said, those Unimods or PinScalers?
Unimods, I think. It came up in the search for Unimod Hamlet, so. And the last thing that I didn't mention along the way was monitoring. You should really take it seriously when you're at least doing the testing, and probably later on, if you're on the hook for keeping the cloud up, care about monitoring. But it's something that sometimes, especially in our world, people don't think about. They're like, they just want to get some shit running. They don't really forgot to actually set up some monitoring NMS, whatever. So especially while you're testing your assertions, hopefully you have the opportunity to map out some ideas for your cloud and actually test it with some realistic workloads. If you're monitoring it, you'll actually be able to develop some useful data. So don't forget about monitoring. Thank you, Christopher Aedo. Questions, conversation is really this meetup, so don't just ask me, let's talk to each other. Thank you.
So yeah, questions?
Yes.
How are you using Nexenta as a block storage? I mean, how are you addressing blocks? Are you using iSCSI or Fiber, or are you just in FS?
So Nexenta Store has an API endpoint and a Cinder. They commit back to OpenStack, and we've worked with them to do some changes too. They have a native Cinder driver. So as far as OpenStack is concerned, you just tell it, here, this is a target for block storage. You can have multiple targets. You now, as a Grizzly, you can use extra fields or extra fields or something like that. There's basically, you can even address those Nexenta stores individually. So let's say you have a cloud with 4 Nexentas in it, and you want to create a volume on each one of those and tie, make sure that it's spread across your Nexentas. It's easy. It's relatively easy to do. That's easy. I mean, super easy. And then in your VM, you can, if you're doing block storage that way in a small cloud, you can know, okay, I'm going to put this volume on 2 Nexentas and or 4 and RAID 10, something like that.
Under the covers, I think, does Nexenta just treat an exposed one as like a single file on a ZFS mount, I thought?
Not a single file. It gets its own ZFS.
It's in a pool.
Yeah.
It's in its own. Okay.
It's its own Z file. Yeah.
Whatever that is, that abstraction is.
And then it comes back through iSCSI
Yes.
to the compute node. Which, going back to the networking and the picture of the shitty hub, super important to 10 gig networking. I mean, even on a 2-node system, if you don't have 10 gig networking, then the first time you snapshot that compute, you snapshot a VM, the compute node will saturate your 1 gig link trying to copy that image back up to their controller or wherever glance is. So you should have why not? It's expensive, but
Not that expensive.
yeah.
Yeah, it's performant. I mean, it's cost comparative. Like we pay roughly the same for a 48-port Juniper EX4550 which is all 10 gig as the equivalent 48-port EX4200, which is all 1 gig.
So I would agree, not that expensive.
Right.
Yeah. They're all
Well
like
worth
10
it.
grand and totally worth it. And in fact, I'm kicking myself for not having done that out of the gate. They were a little more expensive when I built all this, but now they're damn near the same. So.
And a 10 gig card is like 400. I mean, it's like $400, right? $400 or $500.
Yeah.
Nice price.
Yeah, that's just fine.
So what if you can't do 10 gig?
You can
Yeah.
aggregate
What kind
on
of
the 1
specs?
gig ports.
Right.
And things still work even if you have just a single 1 gig ports between everything.
But you probably wouldn't have single 1 gig ports, right? I mean, let's say it's a modern Dell switch and I've got 4 1 gig ports. Bond them, I'm going to be okay?
Yeah,
Yeah.
Okay.
absolutely.
My pre-10 gig model is a pair of 4200s in a virtual chassis config, and every Dell R610, R620, whatever, has the
Right.
4 ports.
Yeah.
It's split across the 2 switches and an OCP trunk, and it does
That's
just fine.
So-
exactly what we would do. Okay.
I probably, the first time I did this talk at the last OpenStack Summit, and I didn't even have graphics. I literally just had a bunch of text, and so I would say cloud controller, and then I talked for 5 minutes about that, and then I got a lot of flack from some people in our company about how boring ass presentation it was, so I added some pictures. What I should add probably is a picture on the software-defined networking side about some sample network architectures, because if you are going SDN, you need a bunch of 1 gig ports and some 10 gig ports. You need a dedicated, distinct management network to handle the flow control, and then usually there will be like a 1 gig network. I mean, depending on the density of your compute node, for a lot of models, 1 gig for outbound is actually fine. 1 gig for outbound is more than Joe average in the public cloud will, shared with 20 people or 30 people on that compute node. I mean, no one is going to pay for more than that, and the people who are paying for more than that are talking to you anyway about a specific kind of stuff. So you do, when you get into the software-defined networking world, you need a little bit more breathing room and elbow room on the networking side.
I'm sorry, so you were saying if you have just a 1 gig outbound, you're fine. So you're saying take the other 3 and bond them and use them?
Well, so let's say you've got four NICs.
Bond the other 2.
Yeah, I mean, I would bond 2 for the internal side.
Just for the internal. So
Just for internal communication, snapshotting,
Storage access.
image distribution.
Right.
So when you, the first time you launch an image, it has to get pulled out of Glance. If you have a small environment, Glance is probably just on a local disk on your your compute node, your control node, and then it caches that image locally. If you have an object store handy, Swift, React, you'll want Glance to use that as the backing, so the compute node will pull it off of Glance. But either way, the first time you launch that image, your compute node has to get that image from somewhere.
Right.
And then when you snapshot it, it pushes it back there.
Okay.
And if you're doing SDN, then you also want a distinct network from your management, and then so your 4 ports, you bond 2 for internal, 1 for management, 1 for external.
Okay, that's great. That's good info.
Yeah, we've bonded all 4 on the box, and the management, the management/22 is untagged, and everything else is a specific tag, which we might shoot ourselves in the foot because that will give storage the ability to step on the service traffic, depending on it. So it's sort of a free-for-all on the networking side of things. We don't really dictate who gets what lane. It's just one big, full duplex 4 gig trunk.
That's kind of what I was planning on doing, but I actually like what he's recommending about just bond 2 and then just, keep it all separate.
Yeah, I think to a larger suggestion of 10 gig peak knowledge expansion now is slap a 10 gig NIC in each and have that be your back-end kind of storage access, and everything up the front side can easily be an LACP bond because LACP doesn't evenly balance traffic, right? The best you can do is on a per CPU stream basis, so you kind of have to take what the traffic profile is into account to decide if that's okay for you or not. Storage usually is better off with a single big pipe because you're not balancing the storage on a per unless it's iSCSI where every single mount is its own TCP session, right?
And what if you're doing local storage? Not as much of a consideration?
I guess it would be less than, but you're giving up things like live migration and other handy features like that.
Yeah, I've learned to live without live migration.
As long as
We're just not a big
You're not
storage.
completely giving it up. I mean, so KVM has live migration on block, so it will do, even if the whole machine image is local, it will move it to another box.
But it's a pause and a copy and a start, right?
Yeah.
So it's not live.
No, it doesn't.
It'll flush it in advance.
It does it. The only time it doesn't work is if the memory dirties faster than it can transfer. So does it transfer, then it transfers the memory and does, I think, 1 more delta or a couple more deltas. There's some point where it keeps trying it, and if it actually won't intelligently fail. If it's dirtying too much, you'll fuck yourself.
Overflow and die.
Isn't it better just to not have live migration?
Well,
Rely on that? I mean,
so here's
just
the
commit to no live migration.
Yeah.
in a smaller setup, that type of live migration with local VM storage is really useful for maintenance because you can evacuate a compute node with just a little blip. I mean, it literally is just a 1 second or 2 second downtime. Sometimes even 1 second.
I never lose more than a ping or two.
Yeah, but that comes in really handy if your compute node is healthy, but you want to take it down and do something to it. When your storage is local, beauty is if you've offloaded that storage elsewhere, that it's an instantaneous or nearly instantaneous migration. migration. Then it only has to copy the RAM essentially for that image and cut it over much faster. And it can cut it over, or you can bring VMs back up kind of at their last state if that compute node dies. But if you have local storage, the ability to migrate can be very handy. So
This stuff's going to be around for years. You know, you're going to end up having to migrate this stuff, especially if it's not.
I think it's better to have a model where the nodes are all fungible and they're just running the load
Exactly.
balancer and you don't care. But
Tear it down and
Oh,
build
yeah.
it somewhere else.
But
I
to your
agree
point
with
of
that.
throwing
Right?
out RDBMS at every chance is the only way you can do that. Otherwise, you still have a MySQL node that is your source of truth for something.
Well,
You gotta
if
do
you're running a
special.
private cloud, nowhere is it written that you have to run the database on your OpenStack cluster.
Exactly.
Sure, yeah.
Database that deserves real hardware, and
Right.
no, I mean that's kind of the model we decided,
yeah.
and we're going to put our DBs on, whatever iron we have, the biggest iron we have, and we'll do everything else VM, and we're not going to migrate anything. We're going to tear it apart and rebuild it somewhere else. And we even talked about, I forget where I heard about this. Somebody was doing something that said no box was older than 30 days. So we actually played around with that, and it's like, I don't know why we make work for ourselves, but
Keep turning them over.
That's
Just
what
keep
Sun
turning
did.
it over.
Remember they had their cluster thing, the Sun Grid, where they were doing rented computing? They didn't pay for any of that hardware. They just took their own hardware out of inventory and said, we're burn-in testing it for 90 days.
no shit.
And then after 90 days, they put it in a box and sell it.
That's genius. My God, that is genius.
I'm personally, in regards to bare metal provisioning, I'm still dragging my feet and waiting. Even though in Grizzly the bare metal provisioning capability exists, it's not integrated with Neutron yet. So you can't dictate that your bare metal node come up on this network, your MySQL bare metal node come up on the right network. You have to have this special little staging network where it pixie boots and does its thing, and then you can roll it over. But I think as of Havana, that's supposed to be solved.
Mhm.
And if it's not, I'm going to have to bite the bullet and go with Puppet Razor or Foreman or something like that, which I don't want to do. But
Yeah.
I'd rather have it be the same consistent provisioning interface inside of Nova. But we'll see.
I mean, for sure, there's a huge driver to fix all of that. Ultimately, I think in the not distant future, the way you'll stand up any cloud is like install one node, and then everything else comes off of that.
Explores.
It'll get easier and easier.
So Chris, what are you seeing out there when you talk to people, potential customers, in terms of why they haven't embraced this?
Fear of complexity, lack of understanding, and there want a VMware replacement. And there have been instances where what you're looking for, you probably should just get bare metal. There's no value to virtualizing it if you're not thinking cloud like what you guys were just talking about, right? That VMs should be basically disposable. And your larger app architecture should account for that and not worry about if of your 6 web layer VMs, one of them dies, who gives a shit? You just spin up another one. And so what we see right now is just a lot of education that needed, that will increase adoption. And there's, part of the problem, when the tape stops, I finish that sentence.
Well, I'll say that if you can be really, really educated on OpenStack and not use it because you're well aware that this is like a development crash course roller derby where not only is it changing wildly every 6 months, but within the releases things are changing like crazy. Configuration options come and go, and lots of luck to you.
Yeah, absolutely. You have to stay on your toes for sure, especially if you're moving fast along with it.
All right, so yeah, let's give Chris a big round of applause. Yeah, thank you for coming and speaking for us.
Thanks, you guys.